Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 9s. Welcome to today's lesson. This is the last live lesson for the year. Wow, well done. We've made it so far. The knowledge area for today's lesson is still planet Earth and beyond. This section contributes 80 marks towards your final examination, so please pay attention and take advantage of the marks because they are relatively easy to get. The topic for today's lesson is mining of mineral resources. And I am your host, Kwanele Dlamini, and this lesson was proudly brought to you by the Gauteng Department of Education. So without any waste of time, let's get right into it. So what are we trying to achieve? What's the goal of this lesson? Why are we doing this? We're trying to ensure that by the end of this lesson, you should be able to list a number of useful minerals found in South Africa's lithosphere. You should be able to recall the two main methods of extraction and refining of minerals from an ore. You should be able to name the location of different mines in South Africa. You should be able to list at least 6 of the main minerals mined in South Africa. And you should be able to identify the provinces in South Africa where large-scale mining occurs. And for more lastly, you should be able to describe the two methods of refining minerals. And for more information on this, you can refer to the Grade 9 CAPS document on page 80. Right. Now, let's get on with our pre-knowledge. In grade 7, we learned about the introduction to the periodic table, of which we also, if you remember, in term 2, we learned further about the periodic table while we were doing the topic of compounds. Right, so this is the periodic table. It has elements, right? It's made up of elements. The periodic table is a classification system for chemical elements. You remember that definition from term 2. And we have 18 groups, which are the vertical columns of the periodic table. And we have 7 periods, which are the horizontal rows. And these groups repeat after every 18th element, right? So this is group 1, group 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. And the periods, they go horizontally, but they increase from top to bottom. The groups, they go vertically, but they increase from left to right. Okay, so this is going to be your first period, second period, third, fourth, fifth, sixth, and seventh. Okay, right. And you remember that each element has its own unique position and its own unique symbol, chemical symbol. Like in this case, they used hydrogen as a standard, right? There is the smallest number within the block is called what? Yes, the atomic number. And the largest number between the two numbers is your atomic mass. Okay, that's good. Right, so your atomic mass is the largest number within the block, and then the atomic number is the smallest one. And then sometimes, occasionally, they will put the name of the element if you have a bigger periodic table, but mostly you're going to find the symbol, the atomic number, and the mass number. Okay, let's continue. In grade 8, we learned about atoms, and we also learned about the relationship between the sun and other planets in the solar system. Okay, so for atoms, let's just do a brief recap. We learned that an atom is a building block of what? An element, right? Or building blocks of matter. And each atom has a nucleus, and inside this nucleus, we have positively charged protons, which are bonded with neutrons, right? The neutrons are neutral. And then around the nucleus, we have negatively charged electrons, which are spinning around the nucleus. And there is a term that we use as a collective for the nuclear, the protons, the electrons, and the neutrons. What is that term? Do you still remember? They are the subatomic particles. So atoms are made up of smaller subatomic particles. Okay, let's continue. And then we learned in our previous lessons about the relationship between the Earth, the Sun, and other planets. We know that the Sun is at the center of the solar system, and around it there are 8 planets. Okay, the first one will be your Mercury, the second one Venus, the third one the Earth, the fourth one will be Mars, followed by Jupiter, Saturn, Uranus, and lastly Neptune. Okay, we have 8 planets. They are all in orbit around the Sun. Okay, then in grade 9 we learned about compounds. What is a compound? What do you remember about the compound? A compound is a substance that is made up when 2 or more different atoms of different elements are chemically bonded. They are joined together by chemical means. Okay, an example will be carbon dioxide, water. In carbon dioxide we have CO2, 2 atoms from oxygen and 1 atom from carbon. In water we have 2 atoms of hydrogen and 1 atom of oxygen, which gives us H2O. Those are compounds. Okay, and this is just an illustration to show you that it involves 2 or more different elements that are chemically bonded to each other. Okay, so now let's do a baseline activity, which is nothing but a few questions that are meant to examine whether you still remember what you've learned. Okay, first question says, name at least 4 valuable minerals that are mined in South Africa. Question 2, what is coke in the industry of mining? Question 3, why is mining important? And lastly, okay, sorry, that's the answer right there. Okay, so you have 3 questions and I've already showed you the answer for the first one, so your job is to answer the other 2. So the first question, name at least 4 valuable minerals that are mined in South Africa. You already have the answer. What is coke in the mining industry? And 3, why is mining important? So you have 3 minutes to work on these 2 easy questions. When you are done, we will continue with our lesson and we will discuss the answers together. Welcome back, learners. I hope you were able to answer those questions. So let's quickly answer them together. What is coke in the industry of mining? Anyone? Yes, that is correct. Coke is a form of carbon, okay? It's a certain type of the element carbon. We use it in the industry of mining, and you will see why and how. Why is mining important? Why is mining important anyway? Anyone? What happens when we mine stuff? Yes, people get paid because there's job creation there, and we gain foreign exchange. So aside from supporting thousands of jobs, if not millions, the mining industry provides raw materials, which are minerals and metals, which can be sold and bring in foreign exchange. Okay, so I hope you were able to answer those questions. Now let's continue. Now let's define a couple of terms that we are going to use in the lesson so that we don't need to consult a textbook in the middle of the lesson, right? Okay. The first term is an ore. What is an ore? An ore is a rock with a large amount of mineral or valuable minerals, okay? It's a rock with a large amount of valuable minerals. Minerals are naturally occurring solids which are crystalline in structures, okay, with a crystalline structure. They are naturally occurring solids with a crystalline structure. They form crystals. Coke is a type of carbon, as we've already explained, made from charcoal and used to extract iron from iron oxide. So that's what we use coke for. It's a type of carbon made from charcoal, which we use to extract iron from iron oxide. Pig iron. Okay, this is not iron made of pig or pig made out of iron. This is iron that has been through the smelting process with coke. So we use coke in the smelting process to extract iron, and this iron is called what? Pig iron. Mining is a process whereby an ore is removed from the ground. Smelting is a process where metal is removed from its ore by melting. So smelting means melting of a metal. Okay, we're melting an ore to remove a metal. Okay, let's continue. Now, let's talk about extraction of an ore. What do we mean by extracting an ore? Okay, what do you think? Yes, that's correct. Extracting means to take out or to remove something from something else. So when we are extracting an ore, what are we essentially doing? We are removing the ore from its source. What is the source? It is the ground, the lithosphere. Remember, we said the lithosphere is rich in minerals. So now we are trying to extract the ore which has these minerals that we are interested in. So in doing that, we use mining, okay? We do mining, and in mining, we make use of machinery and labor force to extract these minerals. We break down rocks under the ground and we bring them to the surface. But let us continue. Right, people have been mining valuable minerals from the lithosphere for thousands of years. So mining is not a new thing. It's been around for centuries. It's been around for a very long time. Okay, people have been doing mining for a very long time for the simple purposes of getting minerals. Okay, these minerals are valuable and we can sell them to get paid. So why not mine them? Okay, minerals are naturally occurring elements or compounds found in the Earth's crust. So the Earth's crust is rich in minerals, and it's part of, remember we said the lithosphere it includes two layers, the upper mantle and the Earth's crust. So the Earth's crust is rich in minerals, and so we go down there to extract these minerals. Now these minerals can be found in the form of elements and compounds. Okay, now rock that contains a large amount of minerals are called an ore. So these minerals are often at times contained within a bigger rock, right? We don't want the entire rock. We are interested in the particular mineral that we need. So we need to extract the entire ore or the rock and break it down to extract what we need out of it. Okay, so rocks that contain large amounts of minerals are called an ore. These rocks are called what? An ore. There are two common ways of extracting minerals from the lithosphere. The first one is surface mining and underground mining. Now, already these two terms can tell us the difference between the two things. You have surface, which is just, okay, on the surface, as the name suggests, and then you have underground, which means you go deep into the ground to extract the ore, okay? So these are two methods that we use. Surface mining occurs when minerals are removed from the surface of the earth. Okay, some minerals are close to the surface of the earth, or they are found on the surface of the earth. So those ones are easy to remove because we just need to extract them using whatever method that we need, and that process is going to be called what? Surface mining. But some of them are hard to get because they are found underground, and those ones require certain methods which are slightly different to the ones that we use on the surface. The ground is excavated and the exposed minerals are removed by drilling or blasting. So for surface mining, what we do is we excavate the earth, okay? We excavate the ground, and the exposed minerals are going to be removed by drilling or blasting, okay? So we just remove the small layer of the ground and then we get our mineral. Unlike in underground mining, we need to go deep into the ground, okay? Right, so blasting will be using explosives to break the rocks that we need, and then we extract what we want. And then drilling is digging the surface to get what we want, but we don't go deep underground. We just drill holes to either break the rock or to remove the layers of the ground, okay? The rock with the valuable mineral is then taken to a treatment plant. Remember, we said this rock is an ore, and it has a lot of things that we are not interested in and the particular mineral that we need. So how do we get the mineral that we need? We need to treat this ore to get the valuable mineral. Okay, we remove all the impurities. Right, so a facility that does this, a treatment plant, would look like this. Okay, we extract the mineral, then we send it to this plant to treat the ore. So imagine this being your ore, okay? It has the desired mineral and undesired minerals, okay? Or particles, okay? Particles of rock that are of no value, and the mineral that has value. So in order to get the mineral that we need to treat this in a treatment plant. Right, so we have a number of different ways of surface mining. The first one is strip mining. So in strip mining, we remove the layer of soil or rocks covering the desired ore. So remember, we mentioned that some minerals are found on the surface of the earth. Maybe they are covered by soil or some rock. We need to remove that rock to get the mineral that we need. So what we do in strip mining, as you can see in the picture, we remove a layer of soil or rock that is covering the desired ore, which is followed by the removal of the desired rock or the desired mineral, okay? So imagine just under the surface here, this is the top ground, and just under there is a desired mineral. So we use strip mining to remove that particular layer so that we can reach what we want underneath. Okay, another one is pit mining, open pit mining. So in an open pit, there is a pit that is like open, okay? There's a pit, a hole, a big hole that is open, and we use that to do the mining, okay? So in open pit mining, it involves drilling of the ground to extract the desired mineral. So we drill the ground to extract the desired mineral because it's covered under that particular ground. So we end up with a pit. Then the last one is quarrying. Quarrying is involved in the removal. Actually, quarrying is the removal of rock and soil or sand, gravel to get the minerals from the ground in order to use them to produce minerals for construction. So when we do quarrying, we use that to get minerals for construction. Okay, and this is what quarrying looks like. Sorry about that. These are all types of what? Surface mining. Okay, we use those minerals for construction purposes. Let's move on. Now let's talk about underground mining. In underground mining, this is when we dig deep holes and tunnels which are dug into the ground. So we go deep into the ground and we build tunnels so that we can move from one location to another without coming back to the surface of the earth, walking around and then going back down. That would be a waste of time. So instead, we dig a hole going underneath the surface so that we can move from the surface to the ground, deep underground, and then from there we make tunnels so that we can move to different locations, and that's where we do the mining. Okay, that's how the mining is done. We dig holes and we have tunnels under the surface, and these tunnels are called shafts. Okay, can go to great depths into the earth. They can go very, very deep into the earth. They are called what? Shafts. Okay. And there are different ways to remove the minerals from the ore. Okay. Because remember, we are digging this ore. Then after that, we need to treat it to get the mineral that we need. So there are many ways of doing that. The ore is extracted using heavy machinery. This is now what? In underground mining. Using heavy machinery and transported to the extraction plant. So we use heavy machinery to dig underground, and then we transport that particular ore into an extraction plant so that we can get the mineral we need. Iron ore, for an example, is heated in a blast furnace with coke. This is how pig iron is produced. So we put iron ore into a blast furnace, which is at a high temperature. So we basically heat up this ore so that we can get the iron, and we add what? Coke into that so that we can get iron, which is called pig iron. Okay. Now gold ore is ground up into a powder. For gold, we extract the ore from the ground, then we ground it into a powder, and then we treat it with sodium cyanide, which is very toxic. Cyanide is very toxic. This dissolves the gold, and then we add zinc and sulfuric acid to form a sludge. A sludge is a mixture of a liquid and a solid. It's like mud. It's a muddy mixture. Okay. This sludge is melted into gold bars. So we take that sludge and we melt it to make gold bars, which we end up selling into the international market and get monetary value in the form of foreign currency. Diamonds, on the other hand, the ore is crushed and then sorted. We use X-ray fluorescence and hand sorting to collect the diamonds. Okay, and these are the diamonds. Sometimes we use grease belts because diamonds can stick to the grease belt better than the other components that are found in the ore. So that's an easy way of extracting diamonds. Now let's look at this map. This is a map that shows mining in South Africa. When you look at this map, you have yellow dots and pink ones of different shapes. So what I need you to pay attention to, because we are going to need these in an activity, we're going to use this to do an activity. The yellow dot or ball is called what? Gold. It represents gold. The pink triangle, platinum. The bluish one is diamonds. The orange one is diamonds in kimberlite or whatever. Then you have the small orange circle, which is copper. The green one is chrome. The reddish one with the dot is iron. The white one is lead. Then the maroon one is manganese. the dark green one with a dot is nickel. This one, which looks dark orange, is titanium. This blue circle is vanadium. This blue, light blue or powder blue with a dot is zinc. And then this one is andalusite. Then the square is coal. The gray square is coal. The orange square with the dot is fluorspar. And then this one is phosphate, and the last one is vermiculite. So we have all of these minerals that are found within South African lithosphere, within the South African lithosphere. So if you look at these maps, which province would you say has the most mines? Well, from what I see, it looks like the Northwest has the most. Okay? Why? Because there's a lot of mines that are there compared to the other provinces. And then you have Gauteng, which looks like it's primarily gold. Gauteng is this small little region over here. Mpumalanga is dominated by coal. This is Mpumalanga. And then Limpopo has a variety of different minerals. Then you have your Free State, which is dominated by gold as well. Then you have KwaZulu-Natal, which is dominated by coal, but not that many. Then the Eastern Cape has just one mine. This is the Eastern Cape. This is the Free State. This is KZN. This is MP. And this is Limpopo. Let's say LP. This is the Northern Cape. In the Northern Cape, there's not that many mines, according to this diagram. But there's quite a number there and there. And then in the Eastern Cape, there's quite a few. No, sorry, the Western Cape. This is the Western Cape. I hope you know the map of South Africa and you know which province is located where. So this is basically what I wanted to illustrate from this diagram. Now, South Africa is very rich in mineral wealth. We have a lot of minerals in this country. Okay? And South Africa has or had huge deposits of gold, platinum, copper, iron, and diamonds. And manganese, chrome, and tin. Okay? So these are the minerals that we are rich in, or were rich in. You have your gold, your platinum, your copper, your iron, diamonds, manganese, chrome, and tin. Most of the valuable mineral deposits are found in Gauteng. Our province is like rich. And Northern Cape, Limpopo, and Mpumalanga. So these are the 4 top provinces with valuable mineral deposits. Not to say that the others don't, but these ones have large mineral reserves. Okay. There is archaeological evidence showing people mined for gold and iron in KwaZulu-Natal and at Mapungubwe many years ago. Okay, so mining is not a new thing, and there is archaeological evidence to suggest that mining has been going on in South Africa for a very long time. Okay, and these archaeological evidence can be found in KwaZulu-Natal and at Mapungubwe. Okay, traditional mining is mining that used to be conducted in the past, the way in which we used to mine in the past. We call it what? Traditional mining. Traditional mining used to be done by hand and was very labor intensive. Can you imagine how difficult it was to mine in the past using your hands to extract minerals from the ground? That sounds very hard. Modern mining, however, we now use machinery which helps us to mine easy, but still will require a lot of labor as well. So modern mining uses a lot of big machinery, however, it's still labor intensive. This machinery need people, okay? We need a lot of people to carry and control this machinery in order to successfully conduct mining. But back in the days, you had to use your hands. Now imagine trying to break an ore with your hands. That sounds terrible. Anyway, now let's do a couple of questions just to test whether we understand what we've covered so far. Where are the most mines in South Africa? B. Outline one main difference between traditional mining and modern mining. You have 2 minutes to work on these 2 easy questions, and your time begins now. Thank you. Right, welcome back, learners. I hope you were able to answer these 2 easy questions. Now, before we discuss the questions together, I would like to remind you of our WhatsApp line, which is 064 748 8913. That's 064 748 8913. If you have a question or you need clarity on anything that we've covered in the lesson, please don't hesitate to ask your question. So now let's do these questions together. Where are most of the mines in South Africa today? And B, outline one main difference between traditional and modern mining. So what do you think? Where are most mines in South Africa today? That is correct. Most mines are located in Gauteng, Limpopo, Mpumalanga, and of course the Northern Cape. These are the areas that have the most number of mines. Not to say that other provinces don't have mines, but these ones have the most. I hope you were able to get that one correct. Question B, outline one main difference between traditional mining and modern mining. What is the difference between the two? Yes, that's correct. Traditional mining involved the use of hands. Okay, it was done using hands. Whereas modern mining, we make use of heavy machinery. Okay, we use machinery, but still we require labor for both. Right, now let's talk about refining minerals. Why do people remove ore from the Earth's crust? Why do we even bother to remove an ore from the Earth's crust? What do you think? Yes, that's correct. Because there's valuable minerals in that ore, so why not? We can make a living out of removing the ore from the Earth's crust and sell it into the international market once we've removed the valuable minerals. Okay, so minerals are naturally occurring elements and compounds found in the Earth's crust. We've already established that, right? Some of these minerals can be used in their natural state, like gold and diamonds and potash, but others like iron and copper need further processing. Okay. Some minerals require physical and chemical processes to extract the materials from the ore or the minerals from the ore. The extraction of iron and copper from an ore has been happening for thousands of years. We've already established that mining is not a new thing. It's been going on for thousands and thousands of years. So what happens once the ore has been removed? Well, it needs to be processed so the minerals can be removed, okay? We need to process the ore so we can remove the desired minerals. We don't want the entire rock. We don't need that. We need the particular mineral, okay? Physical processing involves crushing and milling the rocks which have been dug out of the ground. So there is a method which is physical. It requires physical crushing and milling, okay? So in crushing and milling, we use heavy machinery. We put the ore, there's an input where we put the ore, and there's a crusher inside this machine that crushes the ore into smaller pieces, okay? An example of such a crusher is known as a jaw crusher. It takes the ore and then it breaks it into smaller pieces, okay? That's milling and crushing, okay? The rocks which have been what? Dug from the ground. So in most cases you will see something like this. So imagine you have larger rocks being an input and they are being sent through a conveyor belt to this crusher over here, and then the product will come at the bottom and it's being transported through another conveyor belt, but now it's in small pieces and it comes out there as some powder of some sort. And maybe you have larger pieces which are coming from this direction and they are being sent to a conveyor belt and the larger pieces are collected that side, okay? This is an example of milling and crushing. Okay, the ore is put into machines which crush the rocks into smaller pieces and then put into mills, which then make the rocks even smaller, as we've discussed previously. So imagine these are the rock pieces that are coming out of the crusher, and then we take them and put them in a miller, then they come out as even smaller pieces. Okay, let's continue. The rocks are then put into a flotation tank so the dense ore sinks to the bottom. They can also use huge magnets to remove the ore if it is magnetic. Hematite is an example of a magnetic ore, right? We can just use a magnet to extract the hematite out of an ore. Why? Because it has iron, and iron is what? Magnetic. Okay. And a flotation tank would look something more like this. For those of you who are interested in studying either metallurgy or chemical engineering, you would deal a lot with things like that. Okay, so imagine this is your flotation tank and we are adding the ore in there, and the denser components will sink to the bottom, while the lighter or less dense components will be collecting at the top. So we can separate them easily using that method, because we will collect the denser ones at the bottom, and there's some piping that should be connected there so that we can put it in a storage tank. And usually there is another outlet which is basically a pipe that collects the lighter particles into their own storage tank. But this is a flotation tank. Okay. The ore is then put into a smelter or a furnace to melt the metals inside the ore. Okay. Remember we said smelting is melting. So how can you melt a rock or an ore? Obviously you have to burn it at high temperatures. Okay. So we use a smelter for that purpose. We melt the ore, we burn the ore, we put it in a blast furnace to make it in liquid form at high temperature. Then we can extract the desired mineral out of that. Okay. Other ores have different chemicals added to them to separate the minerals from the ore. So some minerals are very stubborn. They don't want to separate after all the processing that we've talked about. So we need to add certain chemicals so that they can dissociate from the ore and then we can extract them. Okay, so we use certain chemicals to do that. And once you start using chemicals, you're now using what? Chemical processes. So some ores don't need to be physically separated and can be used as it is, like coal. When we extract coal from the ground, we don't need to treat it because we can use as is. You see, coal is easy to use. You use it at its natural form. But for other minerals such as iron, you can't use an iron ore. You need iron to be extracted from the ore. The same applies with copper. Then we have potash. Potash is a compound containing potassium. Potash is used to make fertilizers, which helps farmers to grow crops. Okay, you know we use potassium to make fertilizers. Okay, and these fertilizers are used to grow crops so that we can have food. Okay, it does not need processing once it has been removed from the ground. So this potash doesn't need to be processed because it can be used as is. Most of it is potassium, so we just use as is. But unlike others, it's hard. We need to extract and use, we use milling, crushing, and at times we use what? Chemical processes to extract. So what are the two types of mines? That's the first question. Second question, what is physical processing? Now, because we don't have enough time and there's a lot that we need to cover, we will do these questions together. What are the two types of mines? What do you think? Yes, that's correct. We have surface mining and underground mining. And what is physical processing? Physical processing is when the ore and rocks are broken down into smaller pieces using either a crusher or a miller, okay? Or both. Right, now let's do our first activity. We will do it together as well. Copy and answer the following questions for both surface and underground mining. Okay, so these questions refer to both surface and underground mining. First one, how the ore is mined. So you need to explain how do we mine the ore in surface and in underground mining. B, how the ore is treated after it's extracted. How do we go about treating this ore after extracting it? And C, an example of a mineral that is mined in this way, right? So you need to give an example of a mineral that is mined either using the surface method or the underground method. Okay, so let's not waste any time. Let's just do the activity together. For surface mining, we will start with surface mining. How the ore is mined? Well, we remove the minerals from the surface of the earth. Okay, we can drill and maybe dig a bit and extract the minerals from the surface of the earth. We don't go deep underground. Okay. How the ore is treated after it's been extracted? How is it treated? The ground is blasted or drilled. The rock is taken to an extraction plant to remove the minerals. This is what? Surface mining. We blast the ground or drill the ground, and then we take the rock into an extraction plant to remove the minerals we need. An example of a mineral that is mined in this way will be coal. Okay. Now let's move on to underground mining. For underground mining, how do we mine the ore? Well, to mine the ore, we need to dig holes, right? We dig deep holes which are called a shaft, and we dig them deep into the earth's surface or the crust of the earth. How do we treat the ore after extraction? Well, we bring the ore into the surface or the rock into the surface using heavy machinery. Okay, we use heavy machinery for this one. Then the rock is taken to an extraction plant to remove the minerals. So the methods are similar for both surface and underground. The only difference is that with underground we use heavy machinery first. Okay, then we take it to a treatment plant to remove, or we take it to an extraction plant to remove the minerals. An example of a mineral that is mined in this way will be gold. Okay. Let's move on. So now let's talk about mining of mineral resources, of which is what we've been doing anyway. But let's continue. We have physical processes, okay, physical processing. This involves crushing and milling mined rocks to remove minerals. So we place these rocks in a flotation tank so that the dense ore sinks to the bottom and the less dense ore is floating or at the top. That's why it's called a flotation tank. So then we collect the less dense minerals from the top of the flotation tank, and then the denser one we collect them at the bottom. So it's an easy way to separate using a flotation tank. Then we have something called chemical processing. This is my favorite. Chemical processing, we use further purifying of the metals using chemical reactions. We use chemical reactions to extract these minerals, because some minerals are just that stubborn. They don't want to be removed either through flotation or through milling and crushing. So we need to take a step further to purify them and use chemicals so that they can dissociate from the main ore. Chemicals used include cyanide, which is very, very toxic. Others will be your strong acids, which are also toxic and very corrosive. Remember, we did that in term 2. And chlorine. So these are chemicals that we use, that are commonly used in chemical processing to remove minerals from an ore. Leaching and electrolysis are two types of common chemical processing. We have leaching and electrolysis. Okay. Leaching is the process where the solvent is run in order to remove soluble components. So we add a solvent. A solvent is a substance that causes other substances to dissolve in it. Like water, if you have, let's say, sugar, if you throw sugar into water, it dissolves in the water. Okay, but you need to stir it a bit. Some substances can just dissolve on their own when they are added into a solvent. So in the example of sugar and water, think of water as the solvent and sugar as the solute. Okay, so it is a soluble component in what? In water, the sugar. So the same applies with minerals. In leaching, we add a solvent that causes the ore to dissolve, okay, so that we can get the soluble components out of it. Electrolysis in the other way is this. It is a chemical separation using the conduction of electricity. Electrolysis. Electro has to do with electricity, okay? So that's how you're gonna remember it. Electrolysis is a chemical separation using the conduction of electricity through a melted or dissolved mixture. So we take this mixture and we run some electricity there in order to separate the components of the mixture. It's called what? Electrolysis. Okay, you will learn more about electrolysis and leaching. For most of you that are interested in studying chemical engineering or metallurgy, you will learn more about leaching and electrolysis at varsity. So please work hard, guys, and be chemical engineers or metallurgists. Okay. Right, let's continue. Chemical processing always involves chemical reactions. So whenever you have a chemical process, there must be a chemical reaction. If there is no chemical reaction, then that is not a chemical process. It is rather a physical process. So that's the difference between physical and chemical. Chemical reaction. Physical, no reaction. Okay. Methods of refining. So let's quickly just go over what we've done so far. We have types of refining. These are processes, either physical or chemical. And then we have examples of minerals at the bottom. So physical methods of separating or refining will involve crushing, milling, penning, electromagnetism, hand sorting, fluorescent X-rays, and slicing. And then chemical processes involve smelting, heat, chemicals, cyanide, sulfuric acid, and the addition of oxygen. Remember, when something reacts with oxygen, it's called what? Yes, oxidation. Okay, let's continue. Or combustion. Now let's do 2 more questions, then we're going to move on. Now, state one of the toxic chemicals associated with gold mining. B, which 2 processes are needed to extract gold from its ore or gold ore? Right, so we're going to do these questions together because there's a lot to cover and we don't have enough time. State one of the toxic chemicals associated with gold mining. That will be cyanide. Cyanide is a toxic chemical used in gold mining. Okay, we use it to extract the gold from the ore. Okay, which 2 processes are needed to extract gold ore? Okay, we have 2 processes, the chemical and the physical processes. Okay, the physical is the grounding and breaking and forming a powder, and then the chemical is, yes, we add cyanide, zinc, and what's the other one? Yes, we add strong acids. Okay, so in the processing of gold, we use chemical and physical processes to extract the gold from an ore-bearing rock. Okay, so the physical is when we break and crush the ore, and then the chemical is when we separate the components of the ore from the gold. Okay, let's continue. Now, here's activity 2, which we are also going to do together. You are very lucky today. We're doing everything together. Interesting. Right. So the first question says, which province in South Africa appears to have the most mines according to the given simplified map? Where is this map? Don't panic. I'll show you. Question 2, what province has the greatest variety of mineral resources? Question 3, which provinces appears to have the least number of mineral deposits? I think this should be which province, not provinces. And 4, name the main minerals that are mined in your province. Okay, so here's your map. I would like you to start by doing this question. Okay, we will do it together anyway. But just take a good look of the map and the questions, because question 5 is on the next slide. Okay, but because I love you guys and I really want you to get these things correctly, we will do everything together. Which province in South Africa appears to have the most mines according to the given simplified map? What province has the greatest variety of mineral resources? Which province appears to have the least number of mineral deposits? And 4, name the main minerals that are mined in your province. Okay, I hope you were able to copy those questions because we are moving on now to question 5. Use the map to complete the table below. Okay, so everything is based on the map. So here is your table. You have your provinces and the types of mineral deposits that are found in each of those provinces based on the map that we used. Okay, the first province is Eastern Cape, Free State, Gauteng, KwaZulu-Natal, Limpopo, Mpumalanga, Northwest, Northern Cape, and of course the Western Cape. So you need to give the type of mineral deposits as you can see from your map. I hope you were able to copy this table because you just need to have province and all the 9 provinces and then the type of mineral deposits that are found in each. So now let's do the first question together. Which province in South Africa appears to have the most mines according to the given simplified map? What province has the greatest variety of mineral resources? Which province appears to have the least number of mineral deposits? So the first question, the Northwest, from the map, based on the map, it appears to have the most number of mines compared to the other provinces. What province has the greatest variety of mineral resources? It has to be the Northwest again. Okay. Which province appears to have the least number of mineral resources or mineral deposits? Well, based on the map, the Eastern Cape seems to be having trouble keeping up with the other provinces. The Eastern Cape appears to have one or less than one mineral deposit. Okay, it just has one that I saw from the map. I hope you were able to see it as well. Question 4. Name the main minerals that are mined in your province. This one I'm leaving it to you. What is the main mineral that is mined in your province? First, you need to remember what your province is. And then second, you need to know what is the main mineral that is mined in your province. The province is Gauteng, okay? And the mineral is, say it with me, gold. Okay, good. Let's continue. Question 5. Use the map to complete the table below. Right. So here's our table. What did we see for Eastern Cape? Coal, right? They only have one mine and it has coal. They don't have that many mines. Free State, gold, coal, and diamonds from the map. Gauteng, gold and diamonds, mostly gold. KwaZulu-Natal, coal and gold, mostly coal though. Limpopo, we have gold, Andalusite, titanium, iron, and coal, based on the map. Mpumalanga, that's mostly coal, gold, nickel, and vanadium. Coal is dominant. Mpumalanga has the largest coal reserves in the country. Northwest, it has a lot. Gold, platinum, zinc, Andalusite, fluorspar, chrome, and vanadium. Northern Cape, copper, lead, iron, diamonds, manganese, and titanium. The Western Cape, iron, diamonds, and titanium, but there's very few of them. Okay, I hope you were able to grasp everything that we've done so far, and I hope you are understanding everything that we have done. So now let's summarize our lesson. Rocks that contain a large amount of minerals are called an ore. There are two common ways of extracting the minerals from the lithosphere: surface mining and underground mining. Surface mining occurs when minerals are removed from the surface of the earth while the ground is excavated and the exposed minerals are removed by drilling. This is what surface mining. Underground mining occurs when deep holes and tunnels are dug deep into the surface of the earth, deep underground the earth. Minerals are naturally occurring elements and compounds found in the earth's crust. These minerals are found in rocks called an ore. An ore is dug out of the earth's crust by mining. There are different ways to remove the minerals from the ore. The ore is extracted using heavy machinery and transported to the extraction plant. This is underground mining. Some of these minerals can be used in their natural state, like gold, diamonds, and potash, but others, like iron and copper, need further processing. Some minerals require physical and chemical processes to extract minerals from the ore. Physical means include crushing and milling and to remove the mineral and storing in a tank. Chemical means include chemical reactions such as leaching and electrolysis using chemicals like strong acids and cyanides to purify the minerals. Leaching and electrolysis are two types of chemical processing. Leaching is the process where the solvent is run in order to remove the soluble components. Electrolysis is a chemical separation using the conduction of electricity through a melted or dissolved mixture. Chemical processing always involves a chemical reaction. So now we're going to take time to go through your WhatsApp questions and see how we can help. Well, looks like we don't have questions here. Okay, so without any questions, that brings us back to our lesson. Okay, there are no questions on WhatsApp. So when you finish watching this video, at the bottom of your screen, there's going to be a button that says complete and continue. You click there and you will get a notification telling you that congratulations for finishing your lesson, and you will get bonus points for doing that. Right. That being said, I hope you learned a lot about mining and you understood the concepts of mining and the different methods of refining, extracting, and treatment of an ore to extract the mineral that we need. Okay, now this is the last lesson, so I'm not going to give you a brief preview for the next lesson. What I can say is thank you so much for sticking with me throughout the year while we were doing these live lessons. It's been a pleasure hosting you for this lesson, and I wish you all the best for your examinations as you prepare to start your final exams. All the best from me to you. My name is Kwanele Dlamini, and it's been a pleasure hosting you for this lesson. This lesson was proudly brought to you by the Gauteng Department of Education. Please remember while you're preparing for your exams to take care of yourself, sanitize your hands, wear your mask and keep your distance, and study hard and make me proud. Thank you.